In this video, we're going to talk about an important statistical tool when discussing probability called the fundamental counting principle. The fundamental counting principle says in a sequence of n events in which the first one has k1 possibilities, second event has k2 possibilities, third event has k3, and so on, the total number of possibilities of the sequence will be k1 times k2 times k3 all the way to kn. In this case, and means multiply. So first thing, I'm going to ignore the fundamental counting principle and I'm going to box this here. This is super important. And means to multiply. We're going to see that idea again at some point in this unit. When we see the word and in a statistics problem, we're typically meaning add, or multiply, sorry. Next thing, let's rephrase this. In other words, when we're making n choices, or when we make a series of choices, or if we're performing a statistical experiment, we make several different actions, like roll one die and then roll another die, flip one coin, then flip another coin, draw 5 cards from a deck, 1, 2, 3, 4, 5. Any series of choices or actions, to find the total number of possibilities, we multiply the number of options for each choice. And we're going to do a couple of examples, but first I want to talk about why we use this. So in the last video, we learned that in order to calculate probability, I need to know the size of my sample space, the total number of outcomes, because that's the bottom of my probability fraction. That's my denominator. The fundamental counting rule is one of the tools that we can use to find the size of our sample space for compound situations where we're doing multiple actions or making multiple choices. So we're using this to find the size of our sample space. So let's go ahead and do an example. This example says a local deli has the following options for their sandwiches. And you get choices for bread, meat, cheese, veg, and sauce. So we're making 5 different choices. It says if customers are allowed only 1 choice per category, how many different sandwiches can be made? And we'll ignore the fact that this is a weird deli that only lets you make 1 choice. So I'm making 5 choices. The very first thing I'm going to do is set up that multiplication rule. 5 choices means I'm going to take 5 numbers and multiply them together. And I know that the numbers I'm multiplying together are the number of options for each choice. So for that first blank, I'm looking at bread. That's my first choice for my sandwich. And I see that there's 5 options: rye, white, sourdough, ciabatta, or wheat. So 5 possible choices for bread. In the next column, I see 5 different options for the meat category, 4 for the cheese category, 7 for the veg, and 7 for the sauce. So to figure out the total number of different sandwiches I can make, I just need to multiply those numbers together. So we're going to grab a calculator really quick and do that. So 5 times 5 times 4 times, oops, if my calculator wasn't fighting me, times 5 times 4 times 7, and I get a very large number, 4,900. So according to this deli's menu, I can make 4,900 different types of sandwiches. All right, one more example. You might want to pause this and try it on your own and then come back and check that you did it correctly. This one says, how many 5-digit zip codes are possible if digits can be repeated and if they cannot be repeated? So they actually ask us two questions. The first one is with repeats. The second one is without repeats. So I'm a 5-digit zip code, so in both cases I'm multiplying 5 numbers together. So I'm making 5 choices. Since I'm doing it both times, I'm going to be lazy and I'm going to copy paste. And then when writing those digits down, I know that I'm allowed to use single digits numbers, the numbers from 0 to 9. That's 10 possible choices for that first number. If I'm allowed to use repeats, I also have 10 numbers to choose from the next choice. So all 5 choices I'm choosing from the numbers from 0 to 9. So 10 times 10 times 10 times 10 times 10. And we like multiplying by 10 because we just have a 1 followed by a bunch of zeros. In this case, 5. So if I was only allowed 5-digit zip codes, I get 10,000 possible zip codes if digits can be repeated. The question is, how does that change when I'm not allowed to repeat numbers? So this one we have to think about as we work down the chain. For that first choice, it's my very first number, so I don't have to worry about duplicates yet. I can choose any of the numbers from 0 to 9. 10 choices. But once I've made that choice, I'm taking one of the numbers from the pool. So when I choose my next number, there's only 9 numbers left to choose from. On my third choice, I've taken 2 numbers from the pool. I only have 8 to choose from. And so on down the chain. And I can already see without the multiplication, this number is going to be smaller. Sorry, I'm having a brain fart. Give me a second. Oh my gosh. Nobody called me on it. I said 5 zeros and then I wrote 4. I thought that looked a little weird. There we go. 100,000. When we multiply without repeats, we get 30,240. Which is much smaller. So generally, if you're not allowed to do repeats, your sample size is going to be smaller than if you can do repeats. All right, so that's it for the fundamental counting principle. Reminders that we're using this just to help us find sample space. So this is one step in the process to calculating probability. If you have questions, feel free to send me an email or drop by office hours. Otherwise, I will see you in the next video.